In today's video, here is a nice number theory problem. Here is the following setup. So the equation find all primes such that we have this statement: p square minus 3 times p plus number 8 is a cube. Okay, let's deal with this kind of the problem. Let's put this one on the form of the cube. Okay, so we say p square minus 3p plus 8 is a cube, which is going to written on this form, x cubed. Okay, so the next thing up, I see number 8 here, so I can move this number 8 to the right and make it as a difference of two cubes. Okay, because it is written on the form of 2 cubed. Okay, so let's to see what's giving us this one. So we get here p, let's take p as a common factor as well. We get p is multiplied by p minus number 3 equals x cubed minus 8, which is minus 8, which is same as 2 cubed. Let's factor this one out. We get x minus 2 factor x squared plus 2x plus number 4, like this. Okay, so at this point we know p divides the left hand side of this equation, which means p must be divided right hand side of this equation as well. Okay, so which means p can divide x minus 2, or p can divide x squared plus 2x plus number 4, but it's impossible p can divide both at this time. Okay, let's prove one of these must be out of these possibilities. Okay, let's prove p cannot divide x minus 2. Okay, suppose p divides x minus 2, so we are doing that by absurd proof. So p divides x minus 2 implies p must be inferior or equal to x minus 2. Okay, let's hold this one. Let's save this one for later. We know also p cubed is strictly superior than p squared, because p is a prime. This one is always bigger than this one. Okay, and then also p squared is strictly superior than p squared minus 3p plus number 8. Okay, if you check this one is bigger than this one, because if you plug p as a minimum value, you get 9, you get here 9 0, which is 8, or always you get 9 strictly superior than 8. Okay, if you cancel out p squared from both sides and then move over minus 3p to the right, you get 3p is strictly superior than 8, which is true. Okay, so this one we know exactly equals x cubed. If p cubed, which means p cubed strictly superior than x cubed, which means p must be strictly superior than x. Okay, or x is strictly inferior than p. We already found p which is inferior or equal to x minus 2, which is absolutely impossible, because x is never ever, we get x, because x is never ever smaller than x minus 2. Okay, which is impossible. So if this one is impossible, which means p must divide this one. So this one is a right one. Okay, this one is true. If this one is true, let's work on this one. So we know p divides x squared plus number 2x plus number 4, equivalent according to the divisibility statement. We get x squared plus 2x plus number 4 is a congruent to 0 mod p. Equivalent according to the divisibility statement, we get x squared plus 2x plus number 4 equals n is multiplied by p, or is n is a sum natural number. Okay, so let's take exactly this value of this function and plug it back into this product here. So we get here p is multiplied by p minus 3 equals x minus 2 factor np. So since p is a prime, is different than 0, so I'm going to cancel out p from both sides. So we get here the following: we get p minus 3 equals nx minus 2n. Okay, I'm moving over minus 3 to the right, which means p equals nx minus 2n plus number 3. So I have ended with this expression. We are not going far away, just to take in this value of p and insert it back just into this one. Okay, so we get x squared plus 2x plus number 4 equals n is multiplied by these things here, which is n squared x minus 2n squared plus 3n. Okay, let's make the equation in terms of x as a variable and n as a constant. So if I'm going to do that, I'm simply going to move over this object to the left. Okay, so I get here x squared, then take x as a common factor, plus 2 plus number 2 minus n squared is multiplied by x plus number 4 plus number 2n squared minus 3n equals 0. So now I'm simply going to calculate the discriminant of this one, which is delta. We get delta as a discriminant equals this object square, which is 2 minus n squared quantity square minus 4 times is multiplied by c, which is this one. Okay, I get 4 plus 2n squared minus 3n. Let's simplify this one a little bit. I get 4 minus 4, I get minus 4n squared plus n to the 4th minus 16 minus 8n squared plus 12n. Okay, let's make these things, let's simplify this one more. So I get here n to the 4th as a power minus 4n squared minus 8n squared, which is minus 12n squared, plus these things 4 minus 16, which is minus 12. Okay, minus 12n squared plus 12n plus 4 minus 16, which is minus 12. Okay, let's take this one at the top and continue solving this equation. Previously we were working on this equation and came up with this nice information. We have a relationship between x and p, and we have a delta discriminant for that equation which previously we saw. This delta as a discriminant must be a perfect square in order to gain the integer numbers. Okay, let's transfer this one into inequality. So we know delta, also we know n squared minus 6 quantity squared. So because I am doing this one quantity squared, because I see the first term is going to be the same as this one, and the second middle term is going to be the same, because if you distribute this one, it gets minus 12n squared, which is correct. Okay, now let's add something else on it. So if I'm going to distribute this one, is giving us n to the 4th minus 12n squared plus 36. Okay, but here we have 12n minus 12. Even in order to make this one inferior than this one, we must have 36 is strictly inferior than 12n minus 12. Because this one and this one are the same. The only difference 36 and these two objects. We want to prove this one. If you want this one, must be strictly inferior than this one. So moving over 12 to the left, I get 48 is strictly inferior than 12n. This one is telling us n is strictly superior than 48 over 12, which equals 4. Okay, this is the only condition makes this one. This is the only condition makes this one strictly inferior than this one. So which means I get n squared minus 6 quantity squared must be strictly inferior than this delta, which is a perfect square. Let's build another side of this inequality. Let's put this one n as a n squared minus 5 quantity square to make this one smaller than this one, but we need to check it. But be careful here, n must be strictly superior than 4. N strictly superior than 4 makes this inequality occurred, but we need to check this side as well. So let's check this one. We have n to the 4th minus 10n squared plus 25. Let's make the comparison between this one and this one. So I get the goal object, which is that one right here. I get delta, which is equals to n to the 4th minus 12n squared plus 12n minus 12 is strictly inferior than n to the 4th minus 10n squared plus 25. Let's simplify this one with this one. Minus 12n squared becomes minus 2n squared, because this one is also going to be cancelled out, plus 12n. Let's multiply everything by minus sign. So I get here 2n squared minus 12n plus 37 is strictly superior than 0. Okay, this is for all n is strictly superior than 4, which means n must be superior to 5. Bob number 5, this one is strictly superior than 0 always. Okay, which means this one is always smaller than this one. But the problem, we found a perfect square between two consecutive squares where we have n strictly superior than 4, which is impossible. If this one is impossible, which means n must be inferior to 4, which means n it belongs to this set 1, 2, 3 and 4. Let's put the equation goal which we have previously here. This is the equation what we have been working on. Okay, so this one we applied the delta, we came up with this expression. Now I'm going to plug the values of n here in order to find x. Okay, if you find the x, that means we are going to find p. Let's take the value of n first as the first value. Let's insert it here. I get x squared plus 2 minus number 1, which is 1, 4 plus 2, which is 6, minus 3, which is 3. This one, if we try to factor out this one, x plus half quaternary square is given as x squared plus x plus quarter plus 11 over 4, because 11 over 4 plus this square is given as number 3 here, which is strictly superior than 0, which is impossible to find the solution, which is impossible, which means we have no solution, which means this argument follows similarly to other solutions. This one doesn't work, this one doesn't work, this one doesn't work. Let's check this one. We have n equals 4. Let's plug number 4 into this one here. I get x squared 4 square, which is 16, minus 16 plus 2, which is minus 14, x plus 4. I get 4 square, which is 16. 16 is multiplied by 2, which is 32. 36 minus 12 is giving us 24, equals 0. Let's factor out this one without calculating the delta of this one. I will get x minus 7 quaternary square. I'm going to distribute this one, is given as x squared minus 14x minus 49 plus 24, which equals 25, equals 0, which equals 5 square. We have a difference of 2 squares. Let's factor out that. I get x minus 7. Taking this 5 as a 5 square as a 5 minus 5. Factor x minus 7 plus 5 equals 0. This one is given as minus 12. It's given as minus 2. This one implies x equals 12 and x equals 2. This is only two values. This is the only two values as a solution for this equation. Let's plug this information into the original equation to find p. Okay, so we get here, we get p squared minus 3p plus 8. First solution, I get 2 cubed, which is 8. Cancel out 8 from the left and the right. We get p squared equals 3p. Dividing both sides by p, because p as a prime, p equals 3. Okay, since p is a prime. So this is the first solution. Let's find second solution. We get p squared minus 3p plus 8 equals x cubed, which is 12 cubed. Okay, so solving this equation, you will get p equals 43. Plug in this 43 here, it gets you 1728. Okay, so I have ended this video. If you have any question regarding this problem, just put it in the comment section below. By the way, don't forget to hit the subscribe button and support the channel, and you have a nice day, and thank you for watching and enjoy the rest of your day. Bye.